Hello, hi everyone. Welcome to the Show in the Brand. Today we are going to discuss about electric current, CBSE Grade 10 Physics, CBSE Grade 10 Physics. So in this class, in this we will discuss. In the previous class we discussed about electric current that is so definition of electric current, SI unit of electric current, SI unit of resistance, and relation between resistance and resistivity, and factor depends on resistance. So all those points we discussed. Now we'll discuss about resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination, and their formula we'll discuss now, and their formula we'll see now. Okay, so let's start. I'm taking resistors are connected in series combination. I'm taking three resistors, one, two, three. So these are the three resistors connected in a series combination. Resistors are connected in series combination. I'm taking this a battery, switch I'm considering here. Switch I'm taking. So this is switch. Current is passing through it. Current is passing through it. Current is passing through it. Right? Okay. And across R1, R2 and R3. So there are three resistors. There are three resistors R1, R2, R3. There are three resistors R1, R2, R3. So R1, R2, R3 connected in series combination. Across R1 potential difference V1. Across R2 potential difference V2. Okay, so I'm considering here across R1 potential difference is V1. Across R2 the potential difference is V2. Across R2 the potential difference is V2. Across R3 the potential difference is V3. Okay, so like that I'm connecting. So positive terminal, negative terminal, positive, negative, positive, negative. So current is flowing. So this is a battery. So in series combination, so current is same. In series combination, current is same. In series combination, so current is same. Okay, so that's why I'm taking here. In series combination, current is same. Series combination, current is same. That is, we can take Is equal to I1 equal to I2 equal to I3 equal to I. Okay, so I'm considering here Is equal to I1 equal to I2 equal to I3 equal to I. Right? So current is same. Current is same throughout the circuit. Okay, so I'm considering here. So throughout the circuit, current is same. Throughout the circuit, current is same. Throughout the circuit, current is same. Okay. So I'm taking through Is through whatever the current is flowing from the battery through R1, through R2, through R3. The current is same. That's why I'm taking Is equal to I1 equal to I2 equal to I2, I3 equal to I. But potential difference is different across R1, R2, R3 because different resistors I am taking. Now I am considering here. So potential difference Vs equal to V1 plus V2 plus V3. So potential difference V1 plus V2 plus V3. So here I am considering IRS equal to IR1 plus IR2 plus IR3. So I am taking I common. If you are taking I common, then the values are I. If you are taking common, R1 plus R2 plus R3. So I get cancelled. Then the remaining values are Rs equal to R1 plus R2 plus R3. So resistors are connected in series combination. The formula of resistors are connected in series combination. The formula for resistors are connected in series combination. So Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. So if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Once again, so resistors are connected in series combination R1, R2, R3, three resistors I am taking. Those three resistors, Dimty Chicks, thank you so much. So resistors are connected in series combination. So that's why here R1, R2, R3 are there. So entire the circuit current is same. Entire the circuit current is same. That's why Is equal to I1 equal to I2 equal to I3 equal to I. So current is same. But potential difference is different across the resistors. So potential difference is different is across R1, R2, R3. That's why Vs equal to V1 plus V2 plus V3. So IRS equal to IR1 plus IR2 plus IR3. I am taking common, I get cancelled, the remaining values are Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So this is about resistors are connected in series combination. So if you are taking resistors are connected in parallel combination, if you are saying resistors are connected in parallel combination, we'll see now. Resistors are connected in parallel combination. If resistors are connected in parallel combination, now we will see. So I am taking here. So in parallel combination, you can observe in this parallel combination. So all resistors are connected in parallel combination. All resistors are connected in parallel combination. The potential difference is same. Potential difference is same. Okay, potential difference is same. So across R1, R2, R3, across R1, R2, R3, across R1, R2, R3, potential difference is same. Potential difference is same. Now from Ohm's law V equal to IR, from Ohm's law V equal to IR, I equal to V by R. From Ohm's law, V equal to IR, I equal to V by R. So now we can take here Vp equal to V1 equal to V2 equal to V3 equal to V, because potential difference across R1, R2, R3 is same. That's why I'm taking Vp equal to V1 equal to V2 equal to V3 equal to V. Okay, potential difference is same, but current is different. Okay, so here I'm considering here. So current through R1, I1, R2, I2, R3, I3. So current is different. Current is different across R1, I1 across R2, I2 across R3, I3. So current is different through different resistors. So I'm taking now. Okay. Now if you are considering here, so IP equal to I'm taking IP equal to I1 plus I2 plus I3. Okay, IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So now we are taking common V common. If you are taking V common, then the remaining value is, so 1 by RP equal to, so V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so V will get cancelled. So their value is the value of resistors are connected in parallel combination 1 by RP equal to 1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, now the formula is, so 1 by Rp equal to 1 by Rp equal to n by R. 1 by Rp equal to n by Rp equal to R by N. Rp equal to R by N. Rp equal to R by N. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. 1 by Rp equal to n by R. So this is the formula, that is Rp equal to R by N. So once again you can observe here. Okay. So R1, R2, R3 are connected in parallel combination. R1, R2, R3 are connected in parallel combination. So current is different across R1, R2, R3, but potential difference is same. Potential difference is same. That's why I'm taking Vp equal to V1 equal to V2 equal to V3 equal to V. So current is different. If you want to find out the current, IP equal to I1 plus I2 plus I3, I1 plus I2 plus I3. That's why I'm taking here. V by RP equal to V by R1 plus V by R2 plus V by R3. So V is common. We can take V common. V will get cancelled. The remaining values. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. The formula, if resistors are connected in parallel combination, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this mode resistors are connected in parallel combination. Now, heating effect of electric current. So heating effect of electric current. Heating effect of electric current. Now you can see here. Heating effect of electric current. Heat produced in the conductor. Heat produced in the conductor is directly proportional. Sorry. Normally I am taking V equal to W by Q. V equal to W by Q. W equal to V into Q. W equal to V into Q. Normally P equal to power equal to rate of doing work. Electrical work, that is nothing but VQ by T. VQ by T. So V into Q by T, that is nothing but current. So Q by T is nothing but current. Q by T is nothing but current. Okay. So Q by T is nothing but current. So I equal to Q by T. I equal to Q by T. So now I am considering P equal to V into I. V into I. So we know energy is given to the conductor E equal to P into T. That is equal to VI into T. That is nothing but so H. Heat given to the conductor H. V equal to IR. V equal to IR. V equal to IR. Now you are substituting IR into I into T. Then we are getting I square RT. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Heat produced in the conductor is directly proportional to here you see, so V equal to W by Q, potential difference is equal to W by Q. So here we know W equal to VQ. If you are taking from here W equal to VQ, I equal to Q by T. So power equal to rate of doing work, that is nothing but VQ by T. So V into Q by T. So Q by T is I. So P equal to VI. P equal to VI. So that's enough. So then we are considering, so energy equal to power into T, energy equal to power into T. So V equal to IR, VI into T. So V equal to IR, if you substitute, you will get H equal to I square RT. H equal to I square RT. So H, heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the current is directly proportional to time. So this is about heating effect of electric current. Heating effect of electric current. Okay. So I hope it is very clear. Next we are going to the one more topic, that is, so we'll do some problems related to this one. So we need to do problems. Okay. So we'll start doing problems. So this is a question. This is the question. One check here. One check here. So I'll discuss this question. When a 6 volts battery is connected across a resistor, there is a current of 330 milliampere in the circuit. Find the value of resistance of the resistor. We need to find out the resistance. We need to find out the resistance. Okay. So now you can see this is the battery. This is the battery. So this is the current, battery current. Now you can see find the value of resistance. So V equal to, so V I am considering V equal to given data, given data, given data. What is that? So V equal to 6 volts and current equal to 30 milliampere. 30 milliampere. Okay. So we need to find out R. We need to find out the R. Now V equal to IR formula we can take. V equal to IR formula. But the point is here 30 milliampere is given. 30 milliampere is given. 1 milliampere equal to 30 milliampere is given. 1 milliampere we need to find out. 1 milliampere equal to 10 power minus 3 ampere. 10 power minus 3 ampere. Now substitute the values. So 6 equal to 30 into 10 power minus 3 into R. So R equal to, so 6 by 30 into 10 power minus 3. 30 into 10 power minus 3, right? 30 into 10 power minus 3. Then you will get 6 into 6000 by 30. Okay. So R value, what is the R value? Anybody can tell the answer? What is R value? R value. $200. Yes, 200 ohm. 200 ohm. So this is the answer. So once again check. Once again check here. Okay. So when a 6 ohm battery is connected across a resistor, there is a current of 30 milliampere in the circuit. Find the value of the resistance of the resistor in ohm. So here 1 milliampere equal to 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. Okay. So V equal to 6 volts and I equal to 30 milliampere. R we have to find out. V equal to IR. 1 milliampere equal to 10 power minus 3 ampere. So 6 equal to 30 into 10 power minus 3 into R. From Ohm's law V equal to IR. From Ohm's law V equal to IR we can find out R equal to 6 by 30 into 10 power minus 3. Then 10 power minus 3 will go up. 6000 by 30. So 0 get cancelled. So then we can take 200. So R equal to 200. R equal to 200 ohm. Is it clear? So check once. Okay. Next. Thank you, Krish. So thank you so much. Thank you so much. So we'll go to the next one. Next question. Now you are going to one more problem. We'll discuss one more problem. Let's do. So actually this question already is said. This question will come for 3 marks. I already mentioned this question. Still I am telling. So because that much important it is. So try to do it. So this question will come for 3 marks. Just try this question. So very important. Try this question, 3 marks. Very important for 3 marks. So once read the question. Once everybody read the question. Yes, now you can see here. Now you can see here. Okay. So a charge possessed by an electron. So electron is given. That is, so the number of will flow per second. So per second given. So time is 1 second. Constitute a current in 1 ampere. 1 ampere. So the charge possessed by an electron. Find the number of electrons. We have to find out n. So question is we have to find out n. How to find out n? So that is the question here. So we know the formula I equal to Q by T. So formula is I equal to Q by T. Now Ne by T, right? So I equal to Ne by T. Now I am considering here on one electron, on one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb. So here they already given this one. Now current equal to 1 ampere, current equal to 1 ampere, and time equal to 1 second, time equal to 1 second, current equal to 1 ampere, time equal to 1 second, right? So now you can substitute the values here. 1 equal to n into 1.6 into 10 power minus 19 coulomb by 1. So n equal to 1 by 1.6 into 10 power minus 19. Then if you do it, so 1 by 1.6 into 10 power 19, then n equal to 1 by 1.6 into 10 by 10, then you'll get 10 power 19, then you'll get n equal to, so 0.625 into 10 power 19, then you'll get a 6.25 into 10 power 18 electrons. Okay, so this is the value. N equal to, so 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. So this is the answer. Very, very important. So practice. So 3 marks question is very, very important. For 3 marks, this question is very, very important. Practice once. So be thorough with that. Be thorough with that. Definitely this question, this type of question, either 1 mark, either 3 marks, definitely will come. So MCQ's point of view, very, very important. So either MCQ's point of view, either theory point of view, or a question. Okay, question also they will give. So make sure that you are practicing this one. Okay, so try to work out, try to prepare. So we'll go to the next one. We'll go to the next question, right? Yes. So this question is very, very important. Distinction between terms electrical resistance and resistivity of a conductor. Okay, so differences between resistance and resistivity. Differences between resistance and resistivity. So once again we will discuss. Just will resistance and resistivity. Resistance and resistivity. So first point is resistance formula. Resistance formula is R equal to rho L by A. R equal to rho into L by A. So here in first one, rho equal to RA by L. Second one, SI unit of resistance is ohm. SI unit. Here also SI unit of resistance is ohm meter. Ohm meter. Ohm meter. Third one, symbol I am taking here, symbol. Here also symbol I am taking ohm meter. And the fourth one, so resistance depends on length of the conductor. Resistance depends on length of the conductor and area of the cross section. Depends. So fourth one, so resistivity does not depend on does not depend on length and area. Okay, fifth one, so resistance depends on temperature. Resistance depends on temperature. So resistivity also depends on temperature. And sixth one, resistance depends on material of the conductor. Material. So resistivity also depends on material. Okay. So check once. Is it correct or not? Check once. If any changes are there, let me know. Okay. Once again, very important 3 marks question. This question is for 3 marks. Make sure that you are practicing. So again I am saying very important. Resistance R equal to rho into L by A. Resistivity equal to rho into RA by L. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. So this one very important. Okay, so only derivation. So derivation of resistivity. So 1 mark they may give. 1 mark they may give SI unit of resistivity, ohm meter. Okay, so derivation they will ask. And resistance symbol is ohm. Resistivity symbol ohm meter. SI unit of resistance depends on length and area. Resistivity does not depend on length and area. Okay. So resistance depends on temperature. Resistivity depends also temperature. Resistance depends on material of the conductor. Resistivity also depends on material of the conductor. So these are the factors. So the difference between resistance and resistivity. Resistance and resistivity. So next one we'll go to one more question. We'll discuss now. So problems we'll discuss, as I said, problems. Okay, 2 wires of equal length. I'm reading the question. 2 wires of equal length, one of copper and other of nichrome wire. Nichrome has the same resistance. Which wire will be thicker and why? Nichrome wire. Nichrome wire is thicker because an alloy. Nichrome wire is an alloy of nickel, chromium, manganese and iron metal. So that's why. So 2 wires of equal length, one of copper and other of nichrome have the same resistance. Which wire will be thicker and why? So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. That's why. So it is thicker and okay. So now one more problem. One more problem we'll discuss. Okay, so now try to do this problem. Try to do this problem. So I'm giving time. Explanation at the rate of 610. So now here, use the formula. So you have to identify the question. Here you can see a copper wire of resistivity is given. Resistivity is 1.6 into 10 power minus 8 ohm meter. Cross sectional area is given. Cross sectional area. Calculate the length. Length we have to find out. Okay, resistance also given. So this is the resistivity rho, area of the cross section A and R. Okay, so we have to find out. Now given data. Check the given data. So rho equal to answer. Rho equal to 1.6 into 10 power minus 8 ohm meter. So second one is area of the cross section is 20 into 10 power minus 4. Here centimeter is given, but we have to convert into meter, right? So we have to convert into meter. So that's why here let it first write like this only, then later we'll convert. And length we have to find out. Length, and resistance is 10 ohm. Now 1 meter equal to 100 centimeter. 1 centimeter equal to, so 10 power minus 2 meter. So they given centimeter square. So converted centimeter. 1 centimeter square equal to, so 10 power minus 2 whole square meter square. Then you will get 10 power minus 4 meter square. 10 power minus 4 meter square. Okay. 10 power minus 4 meter square. Then you will get centimeter square. Right. Now substitute the values here. Then we'll get the answer. So A value is 20 into 10 power minus 8 meter square. So that is the A value. Okay. So now formula is, so they are asking to find out L value. The formula is normally R equal to rho into L by A. So from this L equal to RA by rho. Okay. Now L equal to resistance how much? 10. And area of the cross section is 20 into 10 power minus 8. By resistivity is how much? 1.6 into 10 power minus 8. 1.6 into 10 power minus 8, right? So 1.6 into 10 power minus 8. So now you can cancel it. So I'm cancelling. Check once. I'm cancelling 10 power 8, 10 power 8. So if you do 200 by 1.6, 2000 by 16, that is 125. So answer is 125. Length is 125. Check once if it is any changes. Answer is 125. Okay. So this is the answer. Check once the question. Once again, a copper wire of resistivity is 1.6 into 10 power minus 8 ohm meter has a cross section area of 20 into 10 power minus 4 centimeter square. Calculate the length of this wire required to make a 10 ohm resistance coil. So rho given, rho equal to 1.6 into 10 power minus 8 ohm meter. Area of the cross section is 20 into 10 power minus 4 centimeter square. Length we have to find out. Resistance already given. So here 1 meter equal to 100 centimeter, 1 centimeter 10 power minus 2 meter, 1 centimeter square equal to 10 power minus 2 whole square meter square, 1 centimeter square equal to 10 power minus 4 meter square. So R equal to rho into L by A, L equal to RA by rho. So 10 into 20 into 10 power, see here, after solving this one, we will get it this one, A equal 20 into 10 power minus 8. So resistivity is equal to already given. What is resistivity? 1.6 into 10 power minus 8. So 10 power minus 8, 10 power minus 8 get cancelled. So the remaining value is L equal to 125 meters. So this is the answer. Okay. So next question, we'll go to the next one. So do this question, very important question. So here you can see, here you can observe. So the given resistance, so find the ratio of resistance. We have to find out the resistance of, okay, so first write the given data. So given data is, so length Lx equal to 30 centimeter, Ly equal to 10 centimeter. Next, radii of Rx equal to 20 centimeter, Ry equal to 1 centimeter. So we need to find out. So Rx by Ry, that is nothing but, so resistance we have to find out. We need to find out, normally formula is R equal to rho into L by A equal to pi R square. A value, normal area of the cross section is pi R square. Okay, so if you are taking that one, R equal to rho into L by pi into R square, right? Pi into R square. Two centimeter, 2 centimeter. Okay, 2 centimeter only. Two centimeter. Now pi into R square. Pi into R square. Okay, so R is directly proportional to L. R is inversely proportional to radius. R is inversely proportional to radius. Now we'll do it. R square. Now R1 by, so that is nothing but Rx by R. Rx by Ry equal to, Lx by Ly into Rx square by R1 Ry square. Right? Now substitute the values. So you can convert into meter square. You can convert into meter. If you are converting meter also you'll get same, because the meter get cancelled, here also will get cancelled. So you can convert into meter and substitute directly. If you substitute also, so anyway they are asking about ratio. So convert. So if you are taking 10 power minus 2 meter, 10 power minus 2 meter, 10 power minus 2 meter, 10 power minus 2 meter. After solving, so here R square, right? 10 power minus 4 you will get 10 power minus 4. Okay. Now you can check one, substitute Lx equal to 30 by Ly 10 into Rx square is nothing but 2 square only, right? 4. No, actually reverse, right? Inversely proportional here. R is inversely proportional to x square, then Ry whole square by Rx whole square, right? Now Ry is 1 square by Ry, Rx is 2 whole square, then you'll get, so 30, so anyway 0 get cancelled, 3 by 4. Rx by Ry equal to 3 by 4. Is it correct? So let me know, is it correct or not? Okay, check once again I will explain. So listen carefully. Those who are listening, so listen carefully. That is, Find the ratio of resistance of two copper rods X and Y of length 30 and 10 centimeter respectively, and 2 centimeter and 1 centimeter respectively. Lx equal to 30, Ly equal to 10, and Rx equal to 2 ohm and Ry equal to 1 ohm. We know Rx by Ry we have to find out. Rx by Ry we have to find out. For that, so formula is R equal to rho into L by A. R equal to rho into area is pi R square. Is pi R square. So R is directly proportional to length. R is inversely proportional to radius. Here, that's why Rx by Ry equal to Lx by Ly. Ry inversely proportional, right? Ry square by Rx square. So 30 by 10, Lx equal to 30, Ly equal to 10 into Ry equal to 1, Rx equal to 2 centimeters. Anyway, so here 0 0 get cancelled, 3 by 4. This is the answer. Okay, so shall we go to the next problem? So one more problem, right? Just try to solve it. Now you can see here a current of 500 milliampere flows in a series circuit containing a lamp, electrical lamp, and a conductor of 10 ohm. Okay, connected to a battery. Find the resistance of electrical lamp. So RL we have to find out resistance of electrical lamp. Now you can see, write the given data. The given data is first write the given data. Given data. First one, current equal to 500 milliampere, comma 6 volts battery given. So RC conductor resistance given 10 ohm. So conductor lamp resistance we have to find out. Lamp resistance we have to find out. Okay. Now we know 1 milliampere equal to 10 power minus 3. 10 power minus 3 ampere. Okay. So now formula is V equal to IR. V equal to IR formula we can use. So 6 volts equal to 500 into 10 power minus 3 into, okay, R we are giving RC plus RL. So now 6 by 500 into 10 power minus 3 equal to 10 plus RL. Resistance of the lamp you have to find out, right? Resistance of the lamp you have to find out. So now you can see here. So 6,000 if it is goes up, 6,000 by 500 equal to 10 plus RL. Now you can cancel it. If you are cancelling, so 2, so 12, yeah, then you will get RL equal to 10 plus RL equal to 12. RL equal to 12 minus 10, that is equal to RL equal to 2 ohm. This is the answer. Okay. So this is the answer. If you know that, check once whether you are getting correct answer or not. Okay. So we'll go to the next one. Next question. So you can see here how much energy is given to the each coulomb of charge passing through 6 volts battery. So charge is 1 coulomb, potential difference is given. So V equal to W by Q, W equal to V into Q. V is 6, Q is 1, so 6 joule. Answer is 6 joule. Okay. Thank you so much for joining and attending and listening my class. So we'll see again. So at 9 p.m. At 9 p.m. you can join to the class. Okay, so thank you so much. This is your Shiva sir from Student the Brand. If you like this content, do like, share, and subscribe to Student the Brand. Okay, so see you soon at 9 p.m. today.